Now let's consider one of the local area network technologies in more detail. Let's have a look to Ethernet. I already mentioned that Ethernet is the most important technology for local area networks, and originally it was based on a very simple bus topology. The beginnings date back to the early 70s. It was conceived at the Xerox PARC institutes in California. The first Ethernet could link up to maximally 256 computers with a maximal cable length of 1,000 meters and a bandwidth of 2.94 megabits per second. 2.94 megabits a second. Later, IEEE ratified 10 megabits per second broad Ethernet specification, and this Ethernet specification was developed by an alliance of Xerox, the original introducer of the Ethernet, of Digital and Intel. There are three basic components of such an Ethernet local area networks. One has first the Ethernet cable. That's the physical medium the signals are sent. Second component is the algorithm for the use of the common network infrastructure. The one computer which regulates when a computer can get access to this common infrastructure and what's to do in case of collision. So this CSMA CD mechanism is a framework for concurrent access and collision control of the transmission media. And finally, we have the data which are sent within an Ethernet network in form of data packets, which are called frames. So these are the three components. Let's have a closer look to these components, and let's start with the fundamental principles of Ethernet. I already mentioned data packets, so-called frames, are sent along a media, communication media, and this is a cable. Different types of cable determines the different variants of the Ethernet, and this cable, and here the name of the Ethernet comes from, this cable is considered the Ether, or was called the Ether. So we have here the bus, which connects all the computers with each other. The cable, the computer is connected by means of a simple mechanism. And if we, for example, consider here a sender which wants to send the data packets to this computer as a receiver, then Ethernet is a broadcast network. So the packet is sent along this bus to all the computers that are interconnected to this cable. Each computer sees the packet, each computer checks the address of the computer and checks whether this is the own address or not. And only in case of the receiver, here the receiver found its own address, he takes over the packet and hands it over to its operating system. All the other computers that also received the data packet ignore it. How the data packet is sent here, what the computer wants to send, of course, these are groups of, these are information that is encoded in form of bits and bytes. But to be able to send this, the bits and bytes need to be transformed into electrical signals. And this is done by the interface network card, and then the electrical signals are sent along this cable. So it goes into both directions. It goes very fast. There is no logical switch to check something. The electrical signals are sent in both directions. This is the reason that all the computers that are connected to this cable receive each data packet, but only one computer, the receiver, needs to process the data packet. Since all the data packets are sent by means of this sequences of electrical signals along the same cable, we need a mechanism that regulates which of the computer is allowed to send a data packet. And I already mentioned this CSMA CD mechanism. This is the Ethernet multiple access algorithm. And this algorithm regulates how the computers can use the cable, which is used by all the computers, in a certain moment to send its own data packet. Let's assume there is a computer and the computer wants to send a data packet. The data packet is sent, it's transformed into electrical signals, and the signals are sent over the cable. So all the other computers can receive the signals and can check whether the signals stand for a packet for their own computer. This was this broadcast mechanism. But of course, in a cable, electrical signals may be sent only in a certain moment, may be sent only by one computer. Otherwise, there is a possibility of inference and other phenomena, and then the other computers are no more able to detect whether this signal transports a 0 or a 1-bit information. So in each moment, a maximum of one packet, a maximum of one packet can be transferred over this cable. And in the moment, if two packets are transferred simultaneously, then we have the disturbing effect of a collision. Then the signals there's no decryption later possible. So exactly to avoid such collisions and to handle such collisions if they occur, we need a mechanism, and with Ethernet comes with this CSMA CD mechanism. Carrier sense multiple access / collision detection. And this are exactly explaining how this mechanism is working. It rules the current transmission access to the computers, and it helps to resolve collision situation. Let's have a closer look. The ground rules are the following. The ground rules are so-called carrier sensing. And carrier sensing means each of the computers connected to the ether, connected to the cable, listens before it starts to send. And as long as the computer hears or finds out that there is a data transmission, then it is not starting its own transmission. If the ether is busy, it waits for a random time before it starts to proceed. And this time is a so-called back-off time. And there are algorithms which determine this back-off time. The second basic rule is collision detection. So the computers which want to send and the other computers listen to the cable, and in the moment there is a collision, they can find out that there is not a regular use of the networks, that there are overlaid signals and other problems. So if such a collision is detected, the transfer is interrupted, the so-called jam signal sent, which tells the computer both computers or the more computers that just wants to send their package, that it will not work, that the packages are destroyed, and that they have to try to send their packets. The Ethernet offers a connectionless service. Connectionless means there is no connection between the computers to send one package after the other, which belong to the same message. Each packet is sent alone and finds its own way through the network. In this way, Ethernet offers a non non-reliable service. Non-reliable in the sense that the receiver does not get a feedback whether the package was reaching the receiver in a correct way. Of course, the packets, they contain itself some mechanisms for error correction, so they contain, in case of Ethernet, a checksum, but there is no explicit acknowledgement which is sent from the receiver to the sender telling him the packet arrived in good order or in bad order. So neither in case of a success or in case success or in failure, a data packet transmission is acknowledged. If we want to use the Ethernet for providing service with guaranteed service levels and with guaranteed transmission and receiving, then we need protocols of a higher layer to solve this. You mentioned this is exactly the idea, to break down the complex task of communication into several tasks, and on the network layer, on the LAN layer, the task is to organize a packet service as fast, as good as possible, but without any kind of guarantees. How does the Ethernet data packet format looks like? The basic structure of a data packet is the same for all Ethernet technologies. Later on I will show you there's a great variety of different Ethernet technologies, mainly depending on bandwidth and the material that's used for the cable. So all the Ethernet data packets start with a preamble. These are 7 or 8 bytes, and the 7 bytes, they begin with such an sequence 10101010, which alerts the receiver and is helpful for synchronization of sender and receiver. Of course, this is a representation, is a digital representation, and then the 1 as well as the 0 are transformed into a sequence of electrical signals, and then these signals are sent over the network. The last byte of the preamble also ends with such a fixed pattern, 10101011, and this shows that after this, the actual packet comes and is transmitted. So the preamble mainly secures that sender and receiver are in a synchronized status to be able to correctly interpret the signals that stand for the header of the packet as well as for the payload. Then, after the preamble, the header is the next part of such an Ethernet data packet, and here in the header, the destination address and the source address are the main information, each 6 bytes long. And then there are so-called type field. The type field in the header, in the Ethernet header, it identifies the packet as a packet of the Ethernet protocol, as a packet of the data link layer, and then the payload of the packet is transported, and in the Ethernet data packet, the payload may vary between 46 and 1,500 bytes. And then it's finished with a final checksum, and the checksum is 4 bytes long. So this is a format, in principle, the format of an Ethernet packet. I mentioned originally Ethernet starts with a bus topology. The bus topology is this single principle that there is one cable, the Ether, and to this cable the different computers are connected, and then all this computer interconnected to the same wire infrastructure can exchange data packets. So all computers receive the data packets and check and filter out what are the packets that was sent to a specific computer. Beside of the bus topology, we have also the star topology. In the star topology, there is a switch in the middle. It's a hub which takes care that the sender, if the sender wants to send a packet, sender sends this packet to this switch, and the switch finds out, analyzes this data packet, finds out what is the receiver address, and then it forwards exactly to the right receiver the data packet. So this star topology is no more a broadcasting topology. So it was introduced later, particularly in interconnecting different Ethernet segments to each other. Then we have typical network hardware components. We have the Ethernet segment. So this is the cable or the materials that it's used to provide this connection infrastructure, to provide the bus. The bus, each bus, like I showed it in the last slide, they form a so-called collision domain. So this area where packets are broadcasted, where all the connected computers in the same moment get the same data package, this is called a collision domain. And such collision domains, such Ethernet segments, they can be interconnected via the already mentioned hardware, via the already mentioned local area network, special hardware. They can, for example, connected by means of a repeater that connects individual segments into a larger segment. So the segments are interconnected, and then the interconnected networks, they form a new collision domain. So repeater merely freshes up the signals, has no logic to find out is it really necessary to send packets from one domain into another segment. They only refresh signals. Another hardware for the Ethernet technology are bridges. Bridges, they check. They may be used to interconnect such separated collision domains, but after interconnection, the collision domains remain separated. So the bridge is checking whether a packet that is broadcast in this Ethernet segment really needs to be transferred also into the other segment, and the bridge makes this decision exactly if the package is, the addressee of the package is in the other network. But only in that case. If the addressee is not in the other network, then the package is not transferred to the other network. And then we have routers that may connect different Ethernet LANs with each other. At the beginning, I already mentioned that there are many variants from Ethernet, and these variants stand for the technological development. So these Ethernet variants, they distinguish themselves by the transition media. It may be the case that coaxial cable are used, that twisted pair cable are used, that fiber optic cable are used, or others. And they vary according to limiting parameters. For example, the number of computers that may be connected to such an Ethernet, the bandwidth that is provided, the topology. So to mention a few of these variants, we already have seen that IEEE, that the first variant that was standardized was a 10 megabit per second variant. So the bandwidth is the main characteristic of this Ethernet. So we have different variants of such 10 megabit per second Ethernets. So we have 10 base 5. This was original standard. Here expensive cable are used, this so-called thick Ethernet cable. And then we have 10 base 2. This is another 10 megabit per second variant, which is using cheaper cable, the so-called thin Ethernet. And then we have 10 base T. This uses simple telephone cable. that is twisted wire, as a transmission media, and is the star wiring with a central hub. This was used, for example, in buildings to provide a connection to the transmission media in each flat or in on each level. And then I want to mention for this 10 megabit per second variants, the 10 base F variant. And here, this is a variant that uses optical cable. The reason that with a different physical cable, with a different physical nature of the cables, also different error behavior is connected. So optical cable, expensive, but they are relatively error-free. Then there was need for more speed in communication and more bandwidth. Then we have the 100 megabits per second Ethernet. This also often called fast Ethernet. Here, like the name already says, the bandwidth is of 100 megabits per second, and this 100 megabit per second is also able to sustain bursts in multimedia application if there is a burst because different people access the same video or others. The construction principles of this 100 megabit of this fast Ethernet follows the line of development for the 10BT variant. There are also in this case different conductor material is used, twisted pair cable, a shielded double twisted pair cable or fiber optic cable. The characteristic of all these fast Ethernet variants that they use a star topology. And then the development is running fast. Nowadays we have the gigabit Ethernet variants. This originally was developed as a backbone technology for connecting subnetworks with varying bandwidth. But today it's also used within local networks. We have the 10 gigabit per second Ethernet. That was a further development of this backbone technology, and it's often also implemented in metropolitan area networks and wide area networks. We will discuss later. And then the broadband Ethernet. This is a new technology. Here, transmit is no longer done on a digital, on transporting digital basic band signals. Here, different signals are modulated the carrier over several frequencies. So it's an analog transmission compared to the other, which was a digital transmission. And the mechanisms that are lying behind are such a frequency multiplexing procedures of multiple Ethernet systems which can transmit their signals in parallel via such an coaxial cable. To summarize Ethernet technology, it's necessary to have one fixed idea of such a local area network technology before we start to discuss Internet technology. So Ethernet on a glance Ethernet can link about 100 computers in the perimeter of approximately 1 kilometer. It's a relatively high data rate. There are different variants, also different variants in the size. The minimum delay is by sacrificing storage and transport logic. No such storage, no transport logic is broadcasted. It's a very simple addressing scheme. It's a very simple algorithms for accessing the transmission media. It is well experienced way that many users that use the same infrastructure can get a fair access to the communication media. It is highly reliable, no central control. All these are the reason high stability even under load. All these are the reasons that Ethernet is very much used as the network technology in the practical applications.